In this video, we're looking at an application of the exponential function, specifically the example 6 on page 444. It starts on 444, goes to 445 of your textbook. Again, you can view your textbook through My Math Lab. So the question starts out talking about the gray wolf population in the United States in the 19th century and the early 20th century, and how the population has been modified over that course of time. So it says, although the label was undeserved in terms of the insatiable killer, an estimated 2 million wolves were shot, trapped, or poisoned between that time period, specifically because, again, they were assumed to be killers. By 1960, the population was reduced to 800 wolves, and there's a figure that shows the actual population in 2 specific locations of the United States. I'd say just take a minute to look over those. And then it says, shows the rebounding population in 2 recovery areas after the gray wolf was declared an endangered species and received federal protection. Now, this particular question gives you an exponential function, specifically the function f of x is equal to 1145 e to the power of 0.0325x. Now, remember, e is a very special number. It's very much like that of pi. It's 2.71819, so on and so forth. Continues on forever, never to repeat really, and just continues going in terms of a infinite decimal. It is called the natural base specifically because of how it represents a natural growth of specific things in terms of how they just simply populate. Well, this particular function is supposed to model the gray wolf population in the western Great Lakes. F of x is the number of the population. So again, we have to be very careful, make sure when we read these problems, we're very clear about what these things are. F of x represents the population of those gray wolves. And then your x notation. Now this is the tricky part. X represents the number of years after 1978. It is very rare when you're looking at a math problem for x to represent the number of years, because again, our year denotion of how we identify things is seemingly arbitrary. Again, year 0 starts at a very specific location. We have approximately 4,000 years prior to that mapped in terms of information, and then we have scientifically, hundreds of thousands of years, millions of years prior to that, billions of years prior to that, and so on and so forth. But in any case, for every mathematical function, we denote a location of x equals 0. We say this is where time starts for this particular model. And again, the reason why we do that is because it's hard for us to say that our models are going to be universally consistent for that entire section of time. So the question specifically states, according to the model, this is on page 445 now, according to the model, what was the gray wolf population, comma, rounded to the nearest whole number, comma, of the Western Great Lakes in 2014. Now again, what's important about the way that you read these questions is make sure you're really careful about how they're identifying information, as well as how they're asking. So it says, according to the model, this being the model, what was the gray wolf population, I'm going to ignore the rest of it, of the Western Great Lakes in 2014. So I need the population, I need f of x equals question mark. In the year 2014. That's what I have to be able to identify. So the additional piece of it is the in between there is rounded to the nearest whole number. So I need to make sure that I round this to 0 decimals. So with that all being said, all we need to do is we need to figure out how many years after 1978 would be the year 2014. In doing so, we can simply go ahead and subtract these values. You end up with along the lines of 36 years. If I take 36 and add it to 78, I do to get 2014. In this case, again, it's counting years after 1978. So this is counting technically as my 0, and there are 36 years up to 2014. So 36 years is the way that I'm going is the x value that I'm going to pick for this particular information. Again, one more time, it says according to the model, what is the gray wolf population? The population is f of x, so I need f of, and the x value that I'm looking for is 36. So all I have to do is just plug this in, and that's how the basis of these basic exponential applications start out. They get more complicated as we learn how to solve exponential equations. So when I plug this in, I'm simply just going to go ahead and replace my x with what it is. And then again, very carefully typing this into a calculator, again, because you don't have any way to identify what E is other than using the calculator. Again, if you need to see it, there is a way in the calculator to type in E, and then all you're going to do is you're going to go ahead and hit enter. So in my calculator here, I've typed in there e to the power of, I'm going to use 1, and you'll notice that is approximately 2.718. It says 28. It's appropriately, again, more decimals than that, and my calculator has rounded it off. In any case, if I were to type this into a calculator, I'm going to get approximately a value of 3,689.18157 ... And because the question, again, very specifically says round it to the nearest whole number, I'm going to have 3,680. Well, the 9 is where I'm rounding at, so I have to look at the 1. The 1 tells the 9 to stay the same. And that is going to be my population of wolves in that Western Great Lakes area. The second part of this question is, does the model underestimate or overestimate the gray wolf population of the Western Great Lakes in 2014? And this is by how much? Now, the reason why this question, again, this is the part A, there's a bit of work to getting to that part A answer, and then there's a part B. The part B comes from your analysis of the information provided and the mathematical information that you're utilizing. These are two different things. If you look at the graphs very carefully on page 444, again, you're going to want to open up the pages. You're going to notice that in 2014 for the Western Great Lakes, it says there are 3,686. Now, this again is not the mathematical model. This is how many they've actually counted. It says gray wolf population in 2 recovery areas for selected years. So that's the amount. So we have by counting. Okay, we have 3,686, but by our mathematical model, we're at 3,689. So we've overestimated the number of actual wolves there should be. But to be honest, it's not that much of an overestimate. Sure, over more years, it's very probable that this overestimation will skyrocket past what we actually think is going to be true. But at least for this information, we can be certain that this is relatively accurate in terms of how many wolves there should be, and whether or not we can identify, if we needed to know, say in 2018, if the model continues in the pattern that we're working in, can I approximate how many wolves there will be in 2018? Well, yeah, I can approximate that. The issue would be is that I'd approximate it probably by a little bit more than I'd expect to. And again, keep in mind that an overestimate in a linear function would eventually get large after a very long period of time, but an overestimate in an exponential function will rapidly get larger than it needs to be. But this is the basic understanding of how applications of exponential functions work. And for right now, that's all we're going to do for this video, specifically because, again, the focus is on the equation that we're looking on, the function that we're looking on, and the fact that after we're able to solve information, we can go ahead and work through that. I'm going to add one extra question to this particular example, and that question I'm going to add a part C, and that's simply just going to be, well, what is the assumed population of the year 1978? And again, if we're looking for what is the assumed population of 1978 based on this model, well, all you'd be doing is you'd be plugging in 0, because again, the years after 1978, that means that any years after 1978, I'd have to add more values in, but my x value would be 0 if I'm talking about the population at year 1978. So in the year 1978, we would assume that there's 1,145 gray wolves in this area. And again, because if I plug 0 into here, I go from inside out. Multiplication of this times 0 is 0. E to the 0, again, anything to the power of 0 is 0. Anything to the power of 0 is 1. So I have 1145 times 1, which is 1145. So that's something that we can do. If I asked for what's the population in 1978, I could say the population f of 0 would be equal to 1145. And again, that first value in the function is generally going to be your starting value, unless there's additions or subtractions on the outside of that function. But again, that's how you deal with applications of these exponential functions.